The brain interprets and responds to stimulus via the brain. The simplest and smallest part of the system is the neuron. The neuron is surrounded by extracellular fluid and contains intracellular fluid, which are electrically different, and the change in the charge is called the membrane potential, which provides energy for the signal. The electrical charge comes from charged ions such as sodium and potassium, and the movement is permitted and hindered by ion channels. The resting potential is the membrane state of readiness and is negative 70 millivolts, with a higher concentration of sodium outside and a higher concentration of potassium inside the cell, as seen here. When a change in state occurs, the neuron receives a signal from a previous neuron at the dendrite. An influx of positive sodium ions at an internal part of a neuron changes the polarity of the surrounding membrane and is called an excitatory postsynaptic potential. If the potential instead becomes negative, it is called an inhibitory postsynaptic potential. If the chain reaches a certain threshold of excitation through the accumulation of excitatory postsynaptic potentials occurs, an action potential is created through an all or nothing mechanism, as seen here. It involves sodium ions flowing in and potassium flowing out of the cell quickly. The action potential flows through the cell down to the axon terminal in a wave motion. When it arrives at the terminal button, the change in membrane polarity causes calcium channels to open and allows calcium to flow into the cell. Calcium acts as a signal to release the neurotransmitter substance at the presynaptic membrane by excitosis, binds to the postsynaptic receptor, and the cycle begins again. Dravet syndrome is a rare form of epilepsy, usually triggered by hot temperatures and usually presents from 6 months. The symptoms of Dravet syndrome include convulsive seizures, developmental delays, balance issues, and disruption to the autonomic nervous system. The mortality rate for Dravet syndrome is 15 to 20%, usually due to unexpected death in epilepsy or prolonged seizures. Dravet syndrome is 75% of the time caused by a mutation on the SCN1A gene on chromosome 2, causing a premature stop codon, resulting in a non-functional protein, but can also be caused by a mutation on the PCDH19 gene. SC1A gene usually codes for a neural voltage-gated sodium channel NaV1.1. In mice, the loss of NaV1.1 caused a decrease in sodium currents and impaired excitability of GA aerobic interneurons in the hippocampus. NaV1.1 are channels that allow the propagation of action potentials in nerve and muscle cells, and therefore are critical for intercellular communication. The mutation of the gene translates to an improperly folded, poor segment of the protein, leading to inactivity of the channel. In Dravet patients, the mutation causes the development of dysfunctional sodium channels. Thus, those patients develop seizures, as seizures are abnormal connection and interaction of the brain neurons. A mutation in a sodium channel can also cause a severe disruption to the communication between neurons, as they are responsible for the propagation of an action potential. Allow action potentials to flow throughout the neuron in a wave-like formation of sodium entering the cell and potassium leaving the cell through ion channels, and then transferred to another neuron through the process described earlier. CBD-based products have been shown to reduce seizures in epileptic patients because the endocannabinoid receptors react with the cannabinoids and control the way synapses in the brain transmit and regulate the rate at which neurons fire. When the receptors are activated, they activate GABA, which inhibits overactive synapse firing and therefore reduces seizure activity. Epidiolex is the only medication specifically made for Dravet syndrome patients. Its active ingredient is a cannabinoid, and it was approved by the FDA in 2018. It is an oral first-line anti-epileptic medication, as seen here, and is aimed to reduce seizure symptoms and provide specific dosage and guidelines to CBD products, which is usually unusual. Epidiolex can be given to infants, which is important as a large population of Dravet sufferers are infants and children. Epidiolex has been shown to significantly decrease convulsive seizures. 39% reduction with Epidiolex compared to a 13% reduction in placebo when taking a 20 milligram per kilo dosage per day for 14 weeks. 7% of patients taking Epidiolex at the same dosage experienced no convulsive seizures compared to 0% with placebo, as seen here. Epidiolex does have some side effects, such as higher levels of liver transaminase in about 10% of users and lethargy in about 10% of users. In most cases, the benefits of Epidiolex far outweigh the possible side effects, even with pregnant women. Epidiolex has had a significant effect in improving the lifestyle of patients as it improves seizures, which is one of the most severe and lifestyle inhibiting symptoms of the syndrome.